Hello class. For this lecture, we will be talking about protein structures and function. And so as I mentioned previously, the building blocks of proteins are amino acids. And as I mentioned also previously, that carboxyl group needs to be activated. This is the more activated form to react with the amino group to actually have a favorable condition to actually have this condensation happen and forming the peptide bond here. And so as far as the protein structure, the shape is very important because that determines its function. And so we can actually analyze the shape of a protein by using X-ray crystallography. And so an X-ray can pass through a crystal of a protein to produce this diffraction pattern that we can analyze in order to decipher a three-dimensional picture of the protein. And so as an example of the first protein that was analyzed in this way is called myoglobin. And so high levels of myoglobin that is found in your urine is actually something that is very dangerous because it's caused by muscle breakdown. And so athletes especially has to be wary of this because when this type of situation does happen, it actually can be potentially life-threatening if not found early enough. And so as far as with the structure of the proteins, you have different folding that can happen and different interactions with the amino acids. One I already discussed before is that disulfide bond, which is between two cysteine amino acid chains. And then we also have a hydrogen bond interaction, typically between the amino group and the carboxyl group. And then you can have an ionic interaction from different opposite charges of amino acids. And then we can also have this weak van der Waals interaction that can happen between oppositely polarized electron clouds. And then finally, we can have this hydrophobic interaction that's happening within the protein where you have the hydrophobic part of the amino acid chains all clustering in the interior of the protein. And so the structure of the protein has different hierarchy. You have primary structure, secondary structure, tertiary structure, and finally quaternary structure, which is as far as we will get. And so as far as the primary structure, that's mainly built up of covalent bonds, mainly the peptide bonds that I discussed earlier, and also disulfide bonds. And the important thing about a primary structure is its sequence, because any alteration in the structure or sequences actually changes the shape and function of the protein. And that is the building block for making a secondary structure, which is amino acids joined together in a recurring structural pattern. And then the secondary structure is the building block for the tertiary structure. So everything is building on top of each other. The tertiary structure actually gives the three-dimensional folding of the polypeptide. And then that becomes the building block for the quaternary structure, which consists of two or more polypeptide subunits. And so this is a little bit depiction of the hierarchy of the protein structure. So you have this primary structure, once again, mainly peptides and disulfide bonds. And then from there, they can actually interact, forming these beta sheets or alpha helix, and these are formed by hydrogen bonds. And then from there, after you have these foldings of the primary structure to make the secondary structures, then they can also be subunits to make this three-dimensional tetrary structure. And then from there, that is the unit to actually make the quaternary structure. And so once you have all of these structures and all this folding, there is possibilities for proteins to be denatured, so being unfolded. And normally what can cause it is heat, acid, salts, enzymes such as proteolysis, and mechanical aggregation. And that concludes this part of the lecture.